All right, what we're going to do today is we're going to analyze one of the homework problems that people find difficult. It's actually quite an easy problem. I thought we'd just go over this. It's from Projectile Motion number 1, the assignment, and it's from problem number 5. Okay. The problem statement has a young man that's going to be jumping over a puddle, and they've labeled the puddle at 1.5 meters. We don't have a lot of information on this. We know that at some point in his jump, he's going to get to a maximum height of 0.2 meters high off the ground. Okay. Let's write out the givens that they give us in this. All right, so our x initial is 0. And the overall question is just, can he make it across the puddle? Okay, they do give us, so that's what we're looking for is x final. They do give us, however, a horizontal velocity of 3 meters per second. Okay. We can always put in our ax is 0 because we're assuming that this isn't real life and that we are living in a vacuum with uniform gravity and yada yada. Now with our y initial, okay, with our y givens, y initial, y final, these are kind of difficult to think about on this problem because you can split the problem really into two sections. You can think about it in terms of going to the top of the arc or going from the top of the arc down to the bottom. And so in this sense, I'm just going to write out my delta y as 0.2. That way I can just be a little bit more versatile. And I know that my gravity is going to be my acceleration. Okay. Once again, I'm looking for x final. All right, which I have a pretty simple equation for that using constant velocity. My x initial is 0, and I know I got my 3 meters per second for my Vx. However, what I don't know how long it takes. Now, there's just one part of this that may not come intuitively to some of us. The idea is that the amount of time it takes for the person to jump to the top of his arc is the same amount of time it takes for him to fall from the top of his arc. So really, we don't need to solve for this total time all at once. We can just solve for how long it takes him to fall, 0.2 meters, and then times it by 2, and that will represent the entire time. Okay? So we have an easy equation that we have used many times in class, okay, to solve for that kind of information. Okay, this equation is valid if we assume that my y initial is 0. So in other words, we're going to use this equation starting from this point of the diagram. We're starting halfway through his jump. We're assuming, okay, that he's at the very top of his arc. He's about to fall again, and he's going to fall 0.2 meters. So I'm going to say my y initial at this point is 0. The y final is 0.2 meters, and that the initial velocity in the y direction is also 0 because he's at the top of his arc and he's about to fall again. So I can plug in my values. I can go 2 times 0.2 meters. Divided by 9.8 meters per second squared. Notice, since I've designated the top here as 0 and going down is a positive direction, I can make that a positive 9.8. Okay, put that in, and you get a value of 0.20 seconds. Okay? But it's important to recognize that this right here, this is only for half the jump. So when we plug this in up here, we need to plug it in as 0.2 seconds times by 2 because that's going to give us the entirety of the jump. If it takes it 0.2 seconds for him to fall, it also took him 0.2 seconds to get to that height. That's only a valid thought process if we assume that he is jumping and landing from the same elevation. Okay, it doesn't work if the landing spot is lower or higher from where he started. Okay, but seconds cancel here with meters per second, leave me with just meters. Plug all that in, you get 1.2 meters. Okay, there we have a simple example. Okay, 1.2, obviously he doesn't make it over the puddle. He does get wet. But the difficult part of this is just that thought process of knowing that you can break the problem into two pieces and only solve for half the time and then just times it by 2. A lot of people are going to try and solve for the whole time all at once, and that is difficult. Okay, so mull that over. If you have any questions, I know that was kind of quick. If you have any questions, feel free to come in and ask or shoot me an email. Love to go over them with you.